I want it.
I can't believe it.
That car brought his karaoke machine.
Nothing but a heart.
Preston. Coming in. Preston.
Nose, can you turn this thing off, please? This is really cool out here. This is great.
This is your new home now.
These are a lot of keys.
Those are the keys.
You gonna run me through these? 'Cause
We'll get you through this quick, right quick.
It's just insane. I didn't realize how much junk there was.
I'm calling to order a hairdryer from your catalog.
Do you realize what we have on our hands here? This is like the missing link.
You can see everything.
We need to get this guy defrosted because this is gonna be huge. Antarctica. Hello? Hello?
Well, Jennifer, where are you? Good evening. I need to bring my guest in. I lost her. How are you guys? I don't know why I lost Jennifer. She was just there. So what's going on, everybody, while we wait for Jennifer to come in? It's good to see you. And I saw that there was a question about Jim Massa. And let me ask her to come back. I don't know what happened. Come back. She was just here. It's great to see you guys, by the way. Jim, I wanted to tell you that Jim Massa is getting better. He's going to be okay. So let's just wait, and let me say hi to all of you that are here while we're waiting for Jennifer, because we've got quite a show. And she was just here. So Allison Frank and hi, Kristen and Kim, thank you for moderating. And Scott, thank you for moderating. And Bila, hello. Tommyist and Anthony and Looney Tunes, hello. All right, Jennifer said, strap in. We've got a good show, but I don't know what happened to her. So let me see if she's writing me on our chat. Because shit happens when you have a live show, which you all know. Hi, Dee Dee. Live the dream. Yeah, Jim announced publicly that he had COVID. He never got it. Announced it publicly. It's okay to say it. He's going to be okay. He's pretty sure he's going to be okay, but he did announce it publicly. So all of our best wishes to Jim, and she's back. All right. It's okay. She
Very
probably.
exciting.
Yes, it's
Always
very
like high
exciting.
drama. Cool under
High
pressure,
drama.
baby. Cool under
It's
pressure.
there's no pressure, babe. No pressure. It's great to see you. So
Good to see you
everybody
too.
is with us, and I said hi. And Karen Reese, hello. I know you're not going to get all that rain in California, but I just really quick, Steve Angelical, I just really want to quickly say a couple of things about my heart is with everybody out west who this is the first time there has been a tropical storm warning for that area in California ever in recorded history. And a lot of the rain will be in eastern southern San Diego and in the eastern in Death Valley, the deserts. It's going to be quite an event for our friends there that aren't used to this. And then our hearts are with British Columbia. I don't have the town. I had a whole bunch of little clip videos, but we have a big show and people are evacuating. It's 100 miles away from the Arctic Circle where it's burning. Canada's burning. People need to learn about fire science. People need to understand about global warming. People need to understand why these are happening. And I read these comment sections and I am so goddamn sick of hearing about directed energy weapons and the rich people burning it up to buy the land, even in Canada. Come on, guys. Fire science is a thing. So that's all I wanted to say. And I love everybody that, and I've been writing to friends all day. We know Elliot Jacobson, he is in the way. And Groot, our follower Groot, is down there also, and a lot of people in Canada. So if we can just have like 10 seconds and just, think about our people all over, the Maui people, people in China, people in every country experiencing every kind of hardship because of the changing climate. And that's how I wanted to start. So Jennifer, why don't you take it away and give us the synopsis of our tonight's show?
All right. Guys, we're going to dive down to the bottom of the planet, Antarctica, and we're going to get into a couple of different areas. I think you'll find it very interesting. Got a very good slideshow, lots of good stuff to go over there, and some little videoettes. And then we're going to jump into coolantarctica.com. Never heard of coolantarctica.com, but we're going to get in there. Antarctica, pictures, facts, history, and travel. So you can kind of see what it's like. Very beautiful. We're going to jump over then to an article actually all the way back into 2019. And I will tell you how this relates. Part of the Pacific Ocean is not warming as expected. Why? A mystery. Then we're going to jump over to The Week and theweek.co.uk. I'm going to talk about the cold tongue. Cold tongue.
Not ours. Not ours.
Cold tongue. What the Pacific Ocean cool patch mystery says about climate change. And then we're going to jump over to Manga Bay. Antarctic warming alters atmosphere, ice shelves, ocean, and animals. And then give a little homage to NASA in IoT World Today. NASA Rocket Lab to launch climate monitoring satellites.
Yeah.
And that, friends, is where
our show.
That is our show.
That's the show. So we will now be on our slideshow. So here we go. And that's us. And I just want to make sure that, like always, with this, with every single stupid software program, you always got to reset something up. So guess what? We're going to start out with Carl.
The present rate of burning
Love
of
them.
fossil fuels, the present rate of increase of minor infrared absorbing gases in the Earth's atmosphere, that there will be a several centigrade degree temperature increase on the Earth, global average, by the middle to the end of the next century, and that has a variety of consequences, including redistribution of local climates and through the melting of glaciers, an increase in global sea level. There is concern on a somewhat longer time scale about the collapse of the West Antarctic ice sheet and a general rise of many, many meters in sea level. So we have a kind of handwriting on the wall. Certainly there's more research to be done, but as I say, there is a consensus. What can be done about it? The idea that we should immediately stop burning fossil fuel has such severe economic consequences that no one, of course, will take it seriously. But there are many other things that can be done. One has to do with subsidies for fossil fuels. More efficient use could be encouraged by fewer government subsidies. Secondly, there are alternative energy sources, some of which are useful, at least locally. Solar power is certainly one that might be of more general use.
All right. So, Carl.
Everybody's wondering what year that was. I'm wondering too.
It was, I think, in the end of the 80s or the 90s. I'll have to get back and put it in the show notes, because right now, in the top of my head, I don't remember. I'm sorry, guys. Yeah, I know that
Carl Sagan was such a visionary. Billions and billions. Do you remember the billions, Sandy?
Yes. He's an amazing guy.
Awesome.
I do, sweetie. All right, so we're going to go from Carl, and really quickly, I wanted to talk about the Antarctic Treaty System, because basically the Antarctic Treaty and related agreements, collectively known as the Antarctic Treaty System, ATS, regulate international relations with respect to Antarctica, Earth's only continent without a native human population. Wow. It was the first arms control agreement established during the Cold War, setting aside the continent as a scientific preserve, establishing freedom of scientific investigation and banning military activity for the purposes of the treaty system. Antarctica is defined as all the land and ice shelves south of the 60 degree south latitude. Since September 2004, the Antarctic Treaty Secretariat, which implements the treaty system, is headquartered in Buenos Aires. The main treaty was opened for signature on December 1st, 1959. Very good year. Officially entered into force on the 23rd of June, 61. The original signatories were the 12 countries active in Antarctica during the International Geophysical Year of 57-58, which were Argentina, Australia, Belgium, Chile, France, Japan, New Zealand, Norway, South Africa, the Soviet Union, at the time, United Kingdom, and the United States. These countries had established over 55 Antarctic research stations, and the subsequent promulgation of the treaty was seen as diplomatic expression of operational and scientific cooperation that had been achieved. So as of 2021, the treaty has 56 parties. So I thought we would start with explaining this to you, that it is there's no native humans, and it is supposed to be a scientific preserve. And given that, I always like to put a little plug in for my friend Max Delapia, who has this glacier right over here named after him. A glacier that descends the east slope of Craddock Massif and flows between Mount Mole and Effring Peak into the Thomas Glacier and the Sentinel Range in the Ellsworth Mountains in Antarctica. And it was named by the Advisory Committee on Antarctic Names in 2006 after my buddy Colonel Max Delapia, commander of the 109th Airlift Wing, New York, yes, my state, National Guard. And actually, he ran for Congress here, and he would have been a phenomenal. He's just such a great progressive, but of course, the Republican asshole won, and that's the guys who saw. I had his sign out in front of my house, and that's why my mailbox got knocked down.
I remember that.
Yeah.
Oh my God.
And he would have been the best congressman. Instead, we have Nick Langworthy, the useless Trump sycophant. Okay, I'll move on. But anyway, Max, I know you're not watching, but you're a great guy. And so it's very interesting about this advisory committee. I did a little more reading on it, but didn't want to bore you guys all night. So we move on. This is Antarctica. And this was the median, the Weddell. See all the different, the Amundsen, the Ross. Why can't I see the dark?
So the main thing,
Yeah.
the main thing to point out here is the difference between the yellow line and the fuzzy white cloudy stuff, which is the Antarctic sea ice. And in 2023, it was really cutting in. And if you can see the yellow line up by the Weddell Sea, see how much it's changed there?
Mhm.
It's really changed in a lot of different places. So the Antarctic sea ice is on the decline. And we're going to investigate that and look at why that could be and what's gone on with it.
Yep. Okay. We also have an intermission video. I forgot. Oh, okay. This is what it looks like by the different station names. South Georgia, Orcatus, Rothera, Bird, McMurdo, which everybody's heard of McMurdo. I think that's a very famous one. Vostok, Mawson goes by the climate zone, the altitude, and then the temperatures. So I just thought that was a good visual for you guys to see what is Antarctic made up of? You know, what is Antarctica made up of? All right, but now we're going to move on. And Jennifer, take it away.
So you guys, you might remember a couple of weeks back, we showed this, and this is a temperature anomaly map at basically 6 feet above whatever is, the surface, right?
Mm-hmm.
And right away, we talked about the Andes, which are red hot. But what I really want to start to dive into, guys, is this blue blob stuff. These are anomalously cold puddles. Where could these puddles be coming from? Like if the sea is anomalously hot and it's fresh water on the sea, right? So fresh water is much lighter. Even if it's cold, it's not dense because it's not salty and it floats. Where could it come from? Well, probably comes from, you can see some coming out of Patagonia right there. That's the melt in, South America, but also Antarctica. And you can see in particular on the lower left, that big puddle there, that is basically creating anomalously cold air and water. And so because, as the wind sweeps across, it's going to pick up that temperature from the surface of the water if it's anomalously cold. So that's just kind of leading into one of our topics tonight called the cold tongue. What is the cold tongue?
Yeah. Would you like me to move on?
Yes, please, ma'am.
All right.
And this is a little bit of a picture of what that cold tongue could be. So if y'all check out that basically anomalously cold yellow streak going across on the equatorial region, that is making up the cold tongue. And it's very interesting. And it's been The reason I kind of clued into this is I was watching the morning news, and they are covering climate change a little bit more now, thank goodness.
little bit.
And they started talking about the cold tongue, and they're like, for the last 30 years, this equatorial cold tongue in the Pacific has been building up, and it's not going away. And we'd expect, if the seas are warming, that the cold tongue would be warming too, but it's not. And then they said, maybe this is a sign of hope.
Oh.
I'm afraid not. I don't think the cold tongue. They're like, oh, well, maybe it's working. What? This is denial, runs thick. So what the hell,
Yeah.
What the hell?
Not a laughing matter, really.
Yeah. Let's move along. We'll revisit the cold tongue a little bit later. And here's another pictorial of, this looks more like an El Nino anomaly. But in any case, I'm not exactly sure, to be honest, why
That's
I wanted
okay.
to show this.
Because it's a graph. And if Matt Hunter, if you're here, we are showing the graphs, babe.
We're showing graphs.
Yeah.
Well, look. Okay. What about the cold tongue at 0.3? Could that be part of the cold tongue?
0.3. Yeah, see?
Yellow.
I think
coming up. See how it's kind of draping up from Antarctica? And yes, Antarctica is a long way away from the equator, of course. But if you were a continent with an ice cap or ice sheet, up to 2 to 3 kilometers thick, maybe you would be capable of producing a cold tongue with your melt.
Really? I'm telling you. You guys aren't good. I should have named the show
The Cold Tongue.
The Cold Tongue.
The cold tongue. We probably would have gotten a lot of people coming on to see
the Cold Tongue.
Right.
And we didn't even start with our intro, our dancing intro this time. All right, so this is a very interesting one. This is the ice shelves and floating ice tongues that surround Antarctica, cover more than 1.5 million square kilometers, approximately the size of the entire Greenland ice sheet. Conventional wisdom has held that ice shelves around Antarctica lose mass mostly by iceberg decalfing, but recently it has become increasingly clear that melting by a warming ocean may also be important. And this is Rigneau. I think his first name is Eric. He's very famous. I watched.
Rigneau,
Eric. He does
glaciologist.
all of it. Yep. Jen, you want to talk about the actual graph?
Oh, well, it's so interesting, right? These are actual temperatures here. This is not an anomaly, but, clearly the deep purple there, right beside the Antarctic ice shelves, or ice, I guess you would say sea ice, right? In that case.
Yeah.
Sea ice, and if you kind of go up the west coast of South America, you can sort of see, but it's doing this along all the continents, but the cooler air tends to kind of waft up the continent. And then, I don't know, it's very interesting. Look at that yellow kind of cooler area right across the equator. Could that be part of the cold tongue? I'm not sure. I think I just like saying cold tongue. Is what the difference there.
She's a cold-tongued bitch.
I just like saying cold tongue. That's it.
I'm going to have to write a song.
The cold tongue.
The girl with the cold tongue.
Oh,
yeah. All right.
That's great.
So it was an interesting one, but now we have a little entertainment.
A tipping point is something that happens to the climate system that's irreversible on human timeframes. Can't get back to the old climate state, not for potentially millennia. The one that matters for Antarctica is essentially the point at which the ice shelves are all gone. And that will cause very rapid sea level rise above the levels of the current projections. So the Antarctic ice sheet itself sits on continental bedrock. But the ice essentially flows from a high point to a low point, then it hits the ocean, and so it flows onto the ocean, it floats on the ocean, and we call that the ice shelf. The Ross Ice Shelf is a spectacular example. It's the biggest ice shelf in the world, size of France, size of Texas. But there are ice shelves all around the coast of Antarctica, and what these ice shelves do is they hold back the ice flowing off the continent, and they slow down the dynamic flow of ice under gravity into the ocean. Unfortunately, these ice shelves are all melting, they're all thinning because the ocean is warming, and in some places around West Antarctica it's warming a lot. The Larsen ice shelf, for example, the size of England, and it essentially disintegrated in a couple of months. Then what happened? The glaciers feeding the Larsen ice shelf sped up 10 times. So we're seeing that happen all around Antarctica. And what we think is that there will be a threshold whereby the ocean warms and all those ice shelves are going to pretty much go at once, and they're going to go very, very fast. And once they go, then there's nothing to stop the rest of the ice sheet just sliding into the ocean. Now there's another wrinkle here, another instability. So West Antarctica essentially sits in a big bowl below sea level. Large parts of it are 2 kilometers below sea level. So that warm ocean nibbles away at the edges and gets into the soft underbelly. You can imagine you've got this ice sheet flowing into the ocean, but as it retreats into the bowl, the edges of the ice sheet start to lose the grip on the side of the bowl. It's clinging on to the edges, but it's about to slip off. There's nothing for them to hold on to anymore. And so what happens is it's like a bunch of dominoes falling over. These ice cliffs just topple. And we've seen that in Jakobshavn Glacier up in Greenland. You know, it's an incredible thing to watch. These immense ice cliffs, 30 kilometers long, just boom. And if that really plays out at large scale around Antarctica, we're grossly underestimating the amount of sea level rise from Antarctica. Ultimately, the key thing is carbon dioxide warming the climate. The natural climate cycles, which have regulated the ice ages, occur exactly in step with the amount of carbon dioxide in the atmosphere. In other words, it is the pacemaker of Earth's climate. And CO2, the greenhouse gases, and Earth's temperature are totally locked. We know from ice core records and geologic records that you have to go back 3 million years to see a time when our planet last had 400 parts per million carbon dioxide on the atmosphere.
Here we have the Andril drill system sitting here on the Ross Ice Shelf. We made a hole 84 metres.
So one of the areas of research I've spent much of my life doing is drilling sediment cores from around the Antarctic margin. We drilled back to sediments that were 3 million years old to answer that question: when CO2 is at 400 parts per million or higher, what happened to Antarctica? What happened to the sea ice? What happened to the ice sheet? How warm did it get? To give us information about the world we're heading into. And we were able to reconstruct what was living in the Ross Sea, and it was algae. And we know that this algae lives north of the polar front these days in the subantarctics. So we know that the Ross Sea was 5 degrees warmer than present, no sea ice, and we know that the Ross Ice Shelf had collapsed. There is no West Antarctic ice sheet. And not only that, we know from other drilling projects that big parts of the East Antarctic ice sheet also disappeared. Global sea level records from around the world tell us that sea level was about 20 metres higher. So the Paris target says we must limit global warming to less than 2 degrees. And this is one of the reasons. It's a tipping point for the Antarctic ice sheet. Even if we achieve the Paris target, we'll get 50 centimetres of sea level rise in a century. That's baked in from the heat that's already in the system. People underestimate what 50 centimetres really means for us globally. 800 million people around the world are going to be affected by high tide flooding. It's the rising sea level but it's also the storms that are on top of that rising sea level. And so, Hurricane Sandy that wiped out big parts of Manhattan.
Water is splashing over the seawalls at the tip of lower Manhattan.
Those sort of coastal flooding events will be an annual occurrence. And we can't avoid that. That's locked in. So we've got to adapt to living in a warmer world. The latest generation of ice sheet computer models are incorporating these instabilities, predict up to 2 meters of sea level rise a century, unless we aggressively reduce our emissions. People feel it's a hopeless situation, and it's not a hopeless situation. In fact, the science tells us we still have a chance to solve this problem, get on top of it anyway, and avoid the worst. Just in the last few years, we were seeing a sea change in the world. Young people in the streets protesting, pissed off. Politicians starting to take it more seriously, governments starting to really make it a top priority. We can all limit our carbon footprint hugely. It requires a global response. If we take action, we create a better world, both in terms of how we save the climate and in terms of how we save ourselves.
Well, there's always that bit of hopium. But I liked it.
I liked it too. I thought it was a very powerful video.
It was
very
powerful.
poignant though, kind of like sad at the same time,
Yeah. Because I do think he understands the gravity. But it's when there's young people that you're trying to get through to. It's not so easy just to tell them you have no future. So I think that he was responsible in that, the way he handled himself. And so here we go. Take it away, Jen.
Well, we've been talking about the loss of sea ice in both Antarctica and in the Arctic, but also, of course, as we know, the land ice is going away in Greenland, which is right next to the Arctic, and in Antarctica. And Greenland, if you just take a look, they're pretty much on the same scale. So the steepness is real. It's comparable between these two graphs. Greenland is losing ice at this point much, much faster. Antarctica has more recently kind of gotten into the game, and you can see it's steadily losing ice from its ice sheet, in particular in West Antarctica, but East Antarctica is picking up as well. So it is kind of happening right now on a planet near you, and we are losing ice like there ain't no tomorrow.
Right now.
Right
now. And we've got another one from Durham University. We aim to please and educate.
What we did in this research is we looked at the eastern part of Antarctica, which is known as the East Antarctic ice sheet. And the reason we looked at East Antarctica is that it's by far the world's largest ice sheet. It's this giant of ice that covers most of Antarctica. It's so big that it's about 4 kilometers thick in places, and it stores about 52 meters of sea level rise. So if it all disappeared overnight, sea level would be 52 meters higher in the morning, which is quite alarming. That's not going to happen. But what we were interested in is how stable is the East Antarctic ice sheet? Because for a long time, scientists have thought that compared to West Antarctica, compared to Greenland, this ice sheet is more stable, it's less vulnerable. Perhaps we don't need to worry so much about it in a warming climate. But in this research, we looked at times in the past when climate was just a little bit warmer than present. And we looked at the response of the East Antarctic ice sheet, and we found that it retreated. And in some cases, it retreated quite dramatically, perhaps contributing somewhere between 5 and 10 meters to sea level. So there's lessons from the past that tell us that East Antarctica might not be as stable as scientists think. We also looked at satellite observations of where the ice sheet has changed over the last few decades. And again, there were some quite alarming signs, because whilst most of the ice sheet seems to be quite stable, there are some parts that appear to be thinning and retreating and contributing to sea level rise, just like West Antarctica and Greenland are. And although it's only a part of East Antarctica, because the ice sheet's so big, it's a part we need to worry about, because some of these catchments contain maybe 3 or 4 meters of sea level rise just within them. And perhaps the most important part of this research is that we looked at computer model simulations of the ice sheet over the next few centuries. And that was both encouraging but also quite alarming, because what it showed was that the future evolution or the stability of the East Antarctic ice sheet is really sensitive to the emission scenario. So what we found is that under low emission scenarios, particularly scenarios that would see us meet the Paris climate target of about 2 degrees or ideally 1.5 degrees above pre-industrial values, if we can kind of keep our emissions to that temperature target, it looks like the East Antarctic ice sheet will remain intact and will be quite stable over the next few centuries. Perhaps more alarmingly though, was that when we ran the computer models and we looked at the sea level contribution from East Antarctica under a higher emission scenario, under emission scenarios that exceed the Paris Climate Agreement, we start to see several meters of sea level rise. In fact, we could see up to 5 meters of sea level rise by 2500. So what this tells us is that there's an ice sheet there that at the moment is relatively stable, that it will stay stable if we stick to the Paris Climate Agreement, but if we exceed that target, we could see some quite alarming contributions to sea level, and that would be in addition to the contributions that will be made by Greenland and West Antarctic ice sheet. So one of the key conclusions from this research is that we still have this very narrow window to try and meet the Paris Climate Agreement and to protect the world's largest ice sheet. And so in that sense, the fate of the world's largest ice sheet is still in our hands.
And all the scientists will do everything they can. They will. They will.
Mm-hmm. Yeah. Wow, very powerful.
Yeah.
So this is interesting, just to point out, it's a global phenomenon. So what we're looking at here, of course, is the very famous North Atlantic sea surface anomaly graph. Year by year, we're, 2/3 of the way through 2023. And you are here. If you take the T and you go straight up above the T, that is us. There is no place to put this on the graph. So the point is that this is anomalous and immediate, and it is happening right now in particular, and it's been on its way for some time, but now there's sort of, I see this, and I will say tipping point all throughout the world in various places. So this is what's happening in the North Atlantic, updated.
Yeah. And at least in the Pacific, where the Hillary storm is, the temperature is not hot enough to become a tornado. I mean, a hurricane. It's a tropical storm, but it's not as hot as, let's say, Florida area. It's definitely not. And here we go. Antarctic sea ice anomaly. Our friend, Professor Elliott, who's probably going to be rained on pretty heavy.
Yeah, the Antarctic sea ice anomaly this year from January 1st to 2023. It's very hard to see what it's anomalous to because it's a single line and no colors. So I'm not really sure how to interpret this because
I think he did it on purpose, just to show you the standard deviation and below the see. It was it was for dramatic effect on X. Yeah, Elliot does a lot of different kinds, but all right, now here we go again to some conversation.
We're obviously here to talk about the missing Antarctic ice that's made quite a lot of news recently.
Lots of
Can
scientists.
you tell us what has happened? Why is this big news?
Yeah, so we are talking about sea ice here. So that's ice that forms in the ocean each year, and every year in February, and it's got its lowest area, and then it freezes through the winter until September. And what's really caught our attention right now is that this winter, as that freeze up happens, it's much slower than normal. And by one measure, kind of the amount of sea ice that's been missing is at the moment greater than Mexico. So that's how much less ice we've got than what we should normally have at this time of year.
Now, my immediate sort of suspicions are obviously around global warming, but that might not be the whole picture as far as I understand.
Exactly, and it's that whole picture that's the important thing. So we do expect, as the climate warms, that there's more heat in the climate system, but particularly there's more heat in the ocean, and that would cause sea ice to freeze up less readily. And we can see that there is more heat in the ocean around Antarctica now than there has been previously. But as you say, some of the complexities about that are that how that ocean heat has been distributed might be partly to do with natural cycles, but it's unlikely to tell the full story, but it's just very hard to have all the evidence on that. And in addition, we do know that particularly in terms of some of the local changes that have happened, so for example, west of the Antarctic Peninsula, some of those local changes could be more tied to wind patterns. But the extent of the anomalies at the moment are kind of causing quite a lot of climate scientists to say this looks as if it could be the start of a signal linked to climate change.
And would you say this is concerning at this stage? What does this potentially signify?
I think it is concerning. One reason it's concerning for me is just that we don't really understand what's going on. And obviously that's always alarming because that means challenges our ability to make predictions of the sea ice itself, which is important to understand for things like ecosystems. But also it's concerning because sea ice does affect us globally. And so there are a number of ways in which it does that. One is that it affects how much heat the ocean takes up. So sea ice is a reflective layer on the surface of the ocean. If you take that away, you've got a darker surface that absorbs more of the sun's heat, and therefore you're going to heat up the ocean more and the atmosphere more. And we've seen that effect already in the Arctic. Another way that sea ice is important for us globally is that the pattern of sea ice and its formation and melt affects the ocean underneath it. So it affects how the ocean takes up heat and mixes heat down. And that's really important for global ocean circulation. And we can see that that's already changing. And so as sea ice changes more, we could see kind of global effects on ocean circulation.
And just finally then, what will scientists potentially be looking to investigate now to get more information about what is happening?
So one of the real ones is observations in the ocean, I think. So it's very hard to observe around Antarctica, obviously. So we just want to find ways of pursuing getting more observations in the ocean. There's a big symposium happening soon called the Southern Ocean Observing Symposium. And so they'll be discussing, I think, the sea ice part of that will be discussing observations. Another is that we still don't understand how thick the sea ice is, so we can see how much area it covers, but we don't know how thick it is, and it's an ongoing question to improve how we use information from satellites to understand that. And a final one is understanding further what climate models tell us about sea ice in Antarctica.
All right. So we're bringing you the voices tonight of different climate scientists that you guys may not be familiar with.
Yeah, and I kind of want to just call, before we move on, and we can take a look at that graph that they were showing, the multi-year graph with all of the different colors,
I can't fast forward here.
There we go. I'm like disoriented with
I wish I could.
Yeah. Right is left, left is right. But it doesn't matter, but I'm sure everybody here remembers it. And it's different colors, right? Mm-hmm. So this is something that's very interesting. And this is like classic misunderstanding. So the actual height of the Antarctic sea ice, for some years it went up. Why would that be, right? Think about that. The height of the Antarctic sea ice was what? 2014. Mm-hmm. 2014, The Antarctic sea ice was as big as we had ever measured it. And of course, the misunderstanding was like, oh, well, guys, there is no global warming. Look at Antarctica. The Antarctic sea ice is bigger than it's ever been. But of course, it was two interlaced tipping points. And one of them was on land. Antarctica was melting more ice, more water into, fresh, light water. It spreads out like a little pancake, right? And that was happening, but the ocean heat hadn't yet caught up. So it was like not so warm as it is now. And so all that ice or melted water rather, very cold, refroze very easily because it was right on the edge, and now there's a lot more ocean heat and that's not happening. And all of a sudden that was like a false positive, right? And the Antarctic sea ice is like melting a lot more.
That's an interesting way to put it.
Well, because the ocean heat content's caught up and it's pressing in on it, and it's gone past the critical point, so it can't melt because it's above 32 degrees. I mean, it can't form. So there you go. Kind of interesting.
Yeah.
I just
thank you for explaining it. It was good. And they are finding, working to find out how long. This is a project types. It's Horizon Europe. And basically, this is just a little thing. West Antarctic's ice sheet rests partly on frozen seabed. The amount of ice equals 5 meters of sea level rise. Warmer ocean temperatures undermine the ice shelves. This leads to an accelerating loss of ice after passing not yet identified tipping points. West Antarctica loses most of its ice, resulting in practically irreversible sea level rise. So when? That was this research. When? The other scientist had said, okay, 2,500. I mean, that's so abstracted. It's when you use numbers like that, it makes everybody complacent. But he's got models. I'm not going to argue with his science. I'm not an Antarctic polar climate scientist. All right. This is so good. I can't. They're beautiful, aren't they? Oh my God. Oh my gosh.
Oh, so gorgeous.
They really are. Why don't we just look at that again?
Yeah.
Oh. I just want to pick it up and hug it. I love it. And I watch videos, Jen, with hundreds of penguins. I just couldn't show every single video. All right, we have one more to listen to right here, and then we're going to move on.
And that's the kind of emotion that I had when I saw that study that came out a couple of months ago, looking at those the projections of the slowdown of Antarctic bottom water. It was one of those things that scientifically we knew was possible, but actually sort of seeing the magnitude and the rate at which that might be happening, that's the emotion associated with that, is one of, I guess, shock as a scientist that, yes, we knew it was bad, but it's even worse than we thought.
Yes. She is a paleoclimate scientist with research expertise covering natural climate variability and human-caused climate change impacts from the tropical oceans to Antarctica. A wide berth she covers. And her name is Nerly Abram. So we've brought you, and we have one more in the intermission video, good one. We've brought you some different voices. But I got to tell you guys, we're saved. We got Barbie. We've got Barbie. We've got Barbie.
The Eco Leadership Team. That is awesome. Look at that.
Yeah, let me see if I can find our. We got Barbie meows, and Barbie. We've got Barbie, and we will be okay. It is,
Barbie power,
and this
baby.
is the Jane Goodall Institute Barbie, and it's the Eco Leadership Team, 4 dolls made from recycled plastic. Well, I suppose I'd rather have kids playing with this than, horrible, ugly things. At least this gives a powerful message to kids that you could be on the Eco Leadership team, without, scaring a 6-year-old and telling her you're fucked. No, we don't do that. So it was kind of cute, but we're saved, guys. All right.
Yay.
So now we are going to bring up our cool Antarctica. And we're just going to start out really quickly with cool Antarctica. This is a website that basically, I'll put the link in. You can look at everything you want to know about Antarctica. You can look at pictures, facts, history, travel, everything. There's a travel guide, which actually we don't want people to go there. Don't go there unless you're a scientist. But there's everything on this page. And there's facts. It's about polar animals. And then there's all kinds. The wolverine, the polar bears, the moose, the beluga whale, the Arctic wolf. There's so many animals we don't want to lose. Antarctic information. There's quick facts all about Antarctica. There's a lot to know. The history, the science, the environment, everything. So this, I just wanted to bring up really quickly for you guys because you might want to go there and learn more. And then we're going to move on. And Jennifer's going to take it over. And here we go, Jen.
Right, guys. So this is not about Antarctica per se, but it's about the cold tongue. And I think it's related. You tell me what you think. Part of the Pacific Ocean is not warming as expected. Why? This article was originally published in 2019, and this cold tongue has been growing for 30 years. State-of-the-art climate models predict that as a result of human-induced climate change, the surface of the Pacific Ocean should be warming. Some parts more, some less, but all warming nonetheless. Indeed, most regions are acting as expected, with one key exception, what scientists call the equatorial cold tongue. Sorry, I couldn't resist. This is a strip of relatively cool water stretching along the equator from Peru into the Western Pacific, across quarter of the Earth's circumference. It is produced by equatorial trade winds that blow from east to west, piling up warm surface water at the Western Pacific and also pushing surface water away from the equator itself. This makes way for colder waters to well up from depths, creating the cold tongue. Climate models of global warming, computerized simulations of what various parts. I can't help it, man. I'm so sorry. I cracked my own self.
It's better to laugh than cry because, boy, could we cry.
We could cry. This is
And
really
I
bad
do.
because this is basically the tears of Antarctica that are making up the cold tongue. That's my theory. Want to hear what you guys think. So let's start again. Climate models of global warming, computerized simulations of what various parts of the Earth are expected to do in reaction to rising greenhouse gases, say that the equatorial cold tongue, along with other regions, should have started warming decades ago, and it should still be warming now. But the cold tongue has remained stubbornly cold. This troubles many scientists because the cold tongue plays a key role in global climate. For example, it affects the El Niño Southern Oscillation, a natural cyclic strengthening and weakening of the trade winds that cause cooling and warming of the eastern Pacific surface every 2 to 7 years. ENSO is the world's master weather maker, depending on which part of the cycle it is in.
Mm-hmm.
Its echoes in the atmosphere may bring heavy rains or droughts across much of the Americas, East Asia, and East Africa. Whether the cold tongue warms will likely affect weather across huge regions. By shifting, resulting in shifts could affect the world's food supplies, outbreaks of dangerous weather. But our predictions of those shifts rest on climate models. Richard Seeger, a climate scientist at Columbia University's Lamont Doherty Earth Observatory, has long suspected that climate models get the cold tongue wrong. In 1997, he and colleagues published a paper suggesting that it had not warmed at all during the 20th century. At the time, most scientists assumed that any discrepancy between real-world temperatures and those predicted by climate models were due to natural variability. We should just wait. Eventually, the signal of cold tongue warming would emerge. Now, 2 decades later, with a more modern satellite data in hand, real-world observations are veering ever more obviously from the models. It is time to reconsider. In a new paper in the journal Nature Climate Change, he and colleagues used simplified models that isolate the fundamental dynamics of the tropical Pacific atmosphere ocean system. These, they say, comport with the cold tongue's actual behavior and show that it is consistent with rising greenhouse gases. We recently spoke with Sagan about climate models, the intricate workings of the Pacific climate system, and the wider implications for the world. In general, how well do climate models match real-world observations? The mismatch between observed changes in the cold tongue temperature over the past decades and models is quite striking. There are scores of simulations with multiple models from research groups across the world. While these models are all forced by the same histories of greenhouse gases, volcanoes, solar radiation, and other forces, they generate their own internal variability. Hence, they create a range of estimates of climate history. For changes in cold tongue temperature, the observed changes are at the far end of the, observed changes are at the far cold end or outside the model range. The average or median model says the cold tongue should have warmed by 0.8 degrees C or more over the past 6 decades, but the real value is only 0.4 degrees or less.
And there's that graph.
And there it is. There's the cold tongue. My God. There you go.
You were right.
And it's interesting. I mean, I find it's related. I like the second graph better, the one that's a little bit, the next one.
Yeah,
Let me see what you're
bigger.
looking at. Oh, no, that's good. That's fine. Just wanted to see. So that one is actually, I understand it better. And you can see these cold waters that are on the surface of, like, around the sea ice of Antarctica are drifting up the coast of South America and into the cold tongue. I don't think it's like that mysterious. It's growing too, and it's not like a good thing. Well, let's see. What are the state-of-the-art climate models? Why are the state-of-the-art climate models out of line with what we are seeing? So this is like their explanation of the cold tongue. Well, they've been out of line for decades. This is not a new problem. In this paper, we think we finally found out the reason why. Can't wait. Through multiple model generations, climate models have simulated cold tongues that are too cold, which extend too far west. There is also spuriously warm water immediately to the south of the model cold tongues instead of cool waters that extend all the way to the cold coastal upwelling regions of west of Peru and Chile. These overdeveloped cold tongues in the models lead to equatorial equatorial environments that have too high relative humidity. God, this is freaking nerdy. And too it is. It's like confusing me, but it's like, let me see if I can do this thing. I have to concentrate here. I got distracted by the cold tongue.
It's okay. It's Friday night.
Yeah, it's Friday night. What better thing do you have to do? These make the sea surface temperatures very sensitive to rising greenhouse gases. Hence, the model cold tongues warm a lot over the past decade. In the real world, the sensitivity is lower, and in fact, some of the heat added by rising greenhouse gases is offset by the upwelling of cool waters from below. Thus, the real world cold tongue warms less than the waters over the tropical West Pacific or off the equator to the north and south. True nerdity. This pattern of sea surface temperature change then causes the trade winds to strengthen, which lifts the cold subsurface water upward, further cooling the cold tongue. Oh my God, I am so sorry. I could barely get through that one.
But,
it was hard.
What do your models do that the more widely used ones don't? So he's just really talking about the differences between models. And then if your ideas are correct, how might projection of ENSO's future behavior change? What are the implications for people? Many. This is 19, remember. The sea surface temperature of the equatorial Pacific influences climate and its variability worldwide. Generally, warming of that atmosphere influences the climate and its I said that already. I see we're doing really badly on this one. The amount of moisture it's about the amount of moisture the air can hold and intensifies moisture transport. This tends to make subtropical dry zones drier and tropical mid-latitude wet zones wetter. But on top of these changes, there will be regional changes. So if the cold tongue warms as the complex models say it should, analogous to an El Nino event, which we're going to have, so we're going to see, right? It will create a wet tendency in some regions to offset the subtropical drying in the Southwest North America and South America. It will also create a wetting tendency in East Africa, but a drying tendency in equatorial South America and the Sahel. If instead we are right, and the cold tongue will not warm as much, then drying in the Southwest and North America, subtropical South America, and East Africa could be more severe than the complex model projects. And now that this is 2023, we actually could see what they've done since then to see if this has come to fruition.
And on an intuition, I did a search in this article for the word Antarctica. You will notice that the word Antarctica was not really mentioned in this article, but I just had kind of this, I've still got this thing like, I think it's Antarctica that's causing this. And so there are some comments in this article that have to do with Antarctica, and a couple of the comments below, people have figured it out. Yeah, I just did a search on Antarctica to see it. But I was like, I know this is Antarctica. It just feels like it should be, because where else would all that cold water be coming from?
There are some good, guys, I'll put the link in. You'll definitely.
It's like a little mystery. You have to put your little detective hat on.
Right, but we learn.
Right. Figuring out the origin of the cold tongue.
The cold tongue. And here, this is the cold tongue. Yeah, this is August 3rd. So now, by reading this one, we might get a little more of a clue.
That's right.
So who takes this one?
You want me to start and then we'll see?
Yeah, let's tag team. Go for it.
Okay, so cold tongue, what the Pacific Ocean cool patch mystery says about climate change. One part of the Pacific Ocean is baffling scientists, but nobody here, people here know. But the broad trajectory of oceanic temperatures remains clear. So interesting. A thin stretch of the eastern Pacific Ocean has been getting colder for the past 30 years, defying the broad global trend and baffling scientists. The anomaly, known as the equatorial cold tongue, is affecting an area that extends west from the coast of Ecuador for thousands of miles.
Wow.
Over the last 3 decades, the region has cooled by roughly half a degree, and it has scientists wondering how long will hold, said The Atlantic. What is causing the cold tongue? Scientists are not entirely certain what is keeping the cold tongue cool, but Richard Seeger from the Lamont Doherty Earth Observatory at Columbia University said one factor appears to be trade winds in the region, which carry warm water away from the surface, stimulating cooler waters to rise. The trade winds blow from east to west across the Pacific Ocean, Seeger told Newsweek. Because of the rotation of the Earth, the winds drive waters northward to the north of the equator and southward to the south of the equator. As the waters are driven away from the equator, water is pumped up from below, and since the waters below the surface are cold, this creates the equatorial Pacific cold tongue.
There you go.
Yet, despite the effect of these winds, the cold tongue has puzzled scientists because advanced climate computer models suggest that the water should have been warming for decades at a faster rate than the rest of the Pacific due to rising greenhouse gas emissions. Other hypotheses suggest that the answer may be found in the cold seas of the Southern Ocean around Antarctica, which have seen surface temperatures decline in recent decades. Suspected drivers include the melting of Antarctic glaciers as global temperatures rise, and ozone depletion in conjunction with rising greenhouse gas emissions, which are intensifying the movement of cold air from Antarctica. Why does it matter?
Yeah. Why does it matter, Jen?
It doesn't matter. Who cares about the big old tongue?
Cares?
It doesn't matter. It's actually a good thing because
Out of sight, out of mind.
It's a good thing. It's a good thing. This isn't just an academic puzzle. In fact, according to Pedro Dinezio at the University of Colorado in Boulder, it is the most important unanswered question in climate science. Not knowing what is causing it means we also don't know when it will stop or whether it will suddenly flip over into warming. This has huge worldwide implications and could determine whether California is gripped by permanent drought or Australia by ever deadlier wildfires, as well as the intensity of monsoon seasons in India and the chance of famine in the Horn of Africa. More profoundly still, it could even alter the extent of climate change globally by tweaking how sensitive Earth temperature is to rising greenhouse gas emissions. You want to take this one? What are the effects on wildlife?
As well as climate-related questions, I just wanted to say one thing. California is not having a drought right now. At least now, not in the South. They're going to be getting quite a bit of rain. What effects on the wildlife? As well as the climate-related questions it presents, the cold tongue is also an area of interest to biologists, particularly in relation to the Galapagos, which lie 600 miles off of Ecuador. This is because that cold, nutrient-rich water of the cold tongue has become a prosperous patch that feeds phytoplankton and breathes life into the archipelago. According to Judith Decager, a marine ecologist at the Universidad San Francisco de Quito in Ecuador, the ecological impacts of the cold tongue are profound. The cool water sustains populations of penguins, marine iguanas, sea lions, fur seals, crustaceans, or cetaceans, that would not be able to stay on the equator year-round. So colder temperatures can also inhibit coral growth rates. Well, we have a problem with those right now. And fish may experience shifts in their distribution due to changes in water temperature, which can also affect their metabolism and reproduction, said Brillantillo in its explainer on the temperature in the Pacific. So do cooler waters challenge existing climate models? Well as that cold tongue, other pockets of cool oceanic water sporadically present themselves, such as an area of the Pacific Ocean near San Francisco that has recently been the coldest it's been in more than a decade. Perhaps, despite this, the overall direction of the ocean temperatures is going up, and we know that, said Ryan Walter, Associate Professor at California Polytechnic State University. We know that long-term there's climate change and warming, Walter told San Francisco Chronicle. In the meantime, you have these ups and downs. So solving the puzzle of that cold tongue, it isn't about proving climate models wrong, said the new scientist. On the big issues, they have been remarkably accurate. Rather, the cold tongue is the last piece of the puzzle. Fit that in and we can build a more accurate picture of how life will change in a warming world and how best to prepare for the future. So really, the week, they went to all the other publications and they made a pretty cohesive story.
Mm-hmm.
I like it. So are you guys ready for intermission? Because we're having a little bit of a longer show and I would like to get up and stretch. So we do have an intermission video and here we're going to go. So give me a minute to get it up. And
Thwaites Glacier is in Antarctica and is one of the world's fastest changing glaciers. We can talk a bit more about why it's important, but many scientists around the world recognized that it was changing and we needed to understand it better. So the United States and the United Kingdom are partners in a joint project. It's the largest joint project between the countries for Antarctic science ever. We're spending about $50 million to study how Thwaites is behaving. We're working there both on land and at sea and in computer modeling over a period of 5 years. And we are approaching the end of that time period now. Thwaites Glacier has the potential to contribute about 65 centimeters to global sea level rise. So yes, about 2 feet. And that's not going to happen instantly, but it does have the potential to happen rapidly, at least rapidly on the geologic timescale. Already, Thwaites Glacier currently contributes about 4% per year to annual sea level rise. So that's a lot for a single glacier, but it's not alarming. The reason there's so much interest in Thwaites Glacier, warm water is reaching the base. Antarctic glaciers are resting in contact with the ocean. So they're very different than what you might imagine in the Himalayas or the Alps, where ice is up in the mountain. Ice in the Antarctic is in contact with the water. And of course, water is liquid. That means it's above freezing. The ice is solid, it's below freezing. And so that thermal difference right there is what controls the retreat of the ice. Warm water has been found to be impinging or reaching up to the base of the ice. Overall, Antarctic air is very cold. It's very cold in the air. We're not melting ice from the top. It stays frozen. Doesn't rain, it just snows. But if we warm the water underneath the ice, just a tiniest bit, then we're changing that thermal balance and melting the ice from the bottom and destabilizing the ice from that side. 65 centimeters might not sound like a lot, but that's a glacier the size of Florida. And so what that means is that's going to spread out around the planet. Thwaites has the potential to be very catastrophic. So all of West Antarctica, which includes Thwaites, is marine-based ice. And what that means is that once retreat will start, it will get worse. So some places where something changes, it will change a little bit and then stabilize. The retreat of West Antarctic or marine-based glaciers will be positive feedbacks. Once it starts going a little, it will go more, and then it will go more. And Thwaites Glacier is a prime example where as we start to step back, Thwaites will be in deeper and deeper water, making it harder and harder for it to get to its footing. It's like a skier going downhill, and if they start to lose their balance, they're not going to find a place to rest until they get to the very bottom of the hill. Thwaites is like that. Once it starts to lose its footing, it will just get worse and worse. And so some people study the ice from the top, some people study it from satellites. What we do is we work in the ocean, right at the margin of the ice, to understand that interface between the two. You mentioned earlier that the water has been found to be warming right next to the ice. And what that means is we've actually measured water temperatures, and our colleagues and our teams have found that warming signal. My students and I take sediment cores, just like geologists in the oil industry or any other type of geologist. We don't work on ice, we work on sediments. And we take those sediments to find out, was that warm water there in the past? And we are able to look at the chemistry and the microfossils in those sediments and get a hint of when was the warm water there in the past. And one thing that we can say is, at least on a short time scale, this is new. The warm water has just started to impinge in this area in recent decades. Important for conveying to the public what we know about the climate and the potential change. I and all of the colleagues I have, every scientist I know, has exceptionally high confidence in the fact that the ice is retreating. The retreat is accelerating as we watch it, and that there is a expectation that that retreat will continue. So that's high confidence. Accelerating retreat will continue. Only medium confidence in how much it will accelerate. We don't know if it's going to go from contributing 4% to 5%, or 6%, or 10%, or 20 or 50. But we know it's not going to 2 or 1. We know exceptionally well, high confidence, retreat of the ice sheet is accelerating. What we can't say is how rapidly yet. In the UK, and 100 of us are spending our holidays there year after year because we are trying to achieve that confidence. It's a lot easier, of course, to have high confidence in what we can see today than in predictions. But if we, the type of scientists that work in the field, gather enough data, we can help improve the models of the future behavior. Because those models of future behavior are calibrated, they're defined by using the facts we observe about the past. We use the past as a way to calibrate our understanding of the future. So the more we know, the more we can get confident. Yes, that's absolutely our scientific purpose out there.
All right.
That was a good one.
I got it from a different website and I cut the guy out totally. And I am going to send this to her because she's phenomenal. And
Awesome.
I love the way she described everything she did. I learned from her, and adding the music and the graphics, I think she'll like it. I hope.
That's a good thing. Yeah.
As long as he doesn't copyright me, but I doubt it. Anyway, now we're going to move on to Manga Bay. This is our last article. Yes, we're going longer. We only did one show this week, so here we go. And Jennifer, do you want to take this, or do you want me to do it? Start.
We can tag team it like we did the last
All
one.
right,
You want me
'cause
to
this
get
is-
started and
Get
hand
started.
it over?
This is really good.
Okay.
Yeah, Manga Bay.
Right, guys. Antarctic warming alters atmosphere, ice shelves, ocean, and animals. The world's latest record high temperatures are increasingly putting Antarctica's role in regulating global climate and ocean currents at risk. But so far, most signs indicate that the continent has not yet reached a point of no return. A rapid reduction in fossil fuel extraction and carbon emissions still could prevent the worst outcomes. Increased persistence of Antarctic ozone hole over the past 3 years could be an indication of climate change as it cools the solar polar stratosphere through high variability in this phenomenon, and its complexity make casualty difficult to prove. As global warming continues to melt Antarctica's edges, a modeling study shows that fresh water going into the ocean could result in the next 3 decades in a more than 40% slowdown in the currents carrying heat and nutrients northward, essential to sustain ocean life as we know it. If ice shelves melt, allowing Antarctica's ice sheets to float to the sea level rise will escalate. The latest discovery of a new colony of emperor penguins in a marginal habitat in the Antarctic is good news, but also bad news, as it further highlights the vulnerability of the species as Antarctic ice masses destabilize, volatility that threatens their survival. The climate is changing fast, with even Earth's most remote areas unable to dodge the bullet. This includes Antarctica, a region that has long seemed behind the curve when it comes to warming. But how radically or fast the South Polar region's atmosphere, oceans, ice, and land will alter is hard to say. In January, data compiled by the World Meteorological Organization revealed last 8 years as the hottest on record globally. On the Antarctic Plateau, the coldest place on the planet, the Concordia Research Station hit its highest temperature reading ever early in 2022 at negative 12.2 degrees Celsius, which is 10.4 degrees Fahrenheit, while Antarctic sea ice shrank the same year to its smallest extent since record keeping began.
Wonderful.
To 1.92 million kilometers, which is 741,000 square miles. That's an alarming record, but the 2023 beat it at 1.79 million square kilometers. This is potentially bad news for humanity. The white continent, which holds 90% of the world's ice, plays a crucial role in regulating Earth's climate. In an email to Manga Bay, the British Antarctic Survey, BAS, underlined the disproportionate influence the poles have on climate, stressing the contrast between the reflective properties of large white ice-covered areas, which send the sun's heat back into space, and the surrounding dark sea surface, which absorbs the sun's heat, adding to global warming. The big question facing researchers now is whether or not Antarctica is showing signs of hitting an irreversible tipping point. When asked that question by Manga Bay, Matthew England, Scientia professor at the University of New South Wales, responded that Antarctic records will keep getting broken for a while to come, but the extent to which they are broken will be set by our future emission pathways. Put simply, humanity, though on thin ice, still has time to change course, but no one knows precisely how much. Ozone hole persistence, atmospheric variability, or climate trend. The large ozone hole that currently appears annually over the Antarctic was mostly human-caused, the product of the buildup of manufactured ozone-depleting chemicals in the Earth's atmosphere during the 20th century. The landmark Montreal Protocol Agreement in 1987 significantly diminished the size of the hole, reducing the risk of ozone shield complete collapse and many cancers that would have ensued due to direct exposure to ultraviolet radiation from the sun. Scientists flagged a potential new trend in 2022 when the ozone hole took longer than usual to close for the third consecutive year. Annual persistence never seen in the previous 40 years that the Copernicus Atmosphere Monitoring Service had been taking measurements. The Antarctic ozone hole begins enlarging in August, reaches its maximum size in late September, then usually declines in October and closes in November. But for 3 years now, the hole has remained larger than typical throughout November, with closing not occurring until late December. All 3 years also set a record for the slowest warming trends of the stratosphere over Antarctica, which makes climate change suspect as a possible cause of late ozone hole closing. The size of the ozone hole ranked 10th largest in 2020, 8th in 2021, and 12th in 2022. Thanks to the Montreal Protocol, which instituted a phase-out of most manufactured ozone-depleting chemicals, scientists now anticipate that the Antarctic ozone layer will recover to 1980 values by around 2066. With chlorine and bromine in the stratosphere back at their natural levels, or almost, we can be confident that ozone holes will disappear as chemical fuel behind ozone destruction will have been eliminated for good, according to Vincent-Henri Puech, head of CAMS. To Puech, such a question for future research is whether recent ozone persistence might become a trend. He writes, the last 3 years have been marked by strong vortices, or powerful high-altitude winds that circle the Antarctic region, and low stratospheric temperatures, which has led to consecutive large and long-lasting ozone hole episodes. There is a possible connection with climate change, which tends to cool the stratosphere. It is quite unexpected, though, to see 3 unusual ozone holes in a row. It is certainly something to look at further. However, Puech said he believed that it was quite unlikely that 2023 would follow the same pattern. Although stratospheric cooling associated with greenhouse gases increases could be playing a role in preventing ozone hole from healing, it will be difficult to prove this connection using this data alone. This could occur purely by chance and is unlikely the indication of a tipping point. Melting Antarctic ice to impact the world's oceans. You want to take this part, Sandy?
Sure.
From here?
Yep. Okay. Signs of a warming Antarctic climate are especially worrying as melting ice shelves impact Earth's oceans. A modeling study published in March by Australian scientists in Nature found that the Southern Ocean overturning circulation, a network of strong ocean currents driven by deep Antarctic waters that carry heat, carbon, oxygen, and nutrients crucial to the ocean life northward, could slow by more than 40% by 2050 under a high emissions scenario. And we have discussed it on this channel. More recent research conducted by some of the same scientists and released in Nature Climate Change suggested that the Southern Ocean overturning circulation had ebbed by 30% since the 1990s. The cause appears to be Antarctica's melting edges, which, due to climate change, are adding greater volumes of fresh water to the Southern Ocean, lowering the density of about 250 trillion metric tons of salty surface water each year, which reduces its ability to sink and drive the deepest flows that separate nutrients to the world's other ocean basins. If our model simulations turn out to be correct, it is difficult to see the Antarctic overturning circulation surviving beyond 2100, said UNSW's England, who co-authored both studies. Given the amount of meltwater observed at just over 1 degree Celsius, 1.8 Fahrenheit, of warming planet-wide, he suggested that a collapse of the currents would be highly likely above 2 degrees C, 3 degrees or 3.6 F, over pre-industrial levels. So scientists expect average global temperatures to increase in the next 5 years, temporarily rising about 1.5, fueled by global warming and a powerful El Nino event now gathering strength in the eastern Pacific Ocean. The 2 degrees C threshold could be reached by as early as 2050, according to a dire warning just issued by climate scientist James Hansen, though most researchers say that that point will more likely come later on the century if humanity does not drastically curb emissions. But that's not the only peril originating at the Antarctic's melting margins. The biggest threat to the Antarctic's ice sheet, leading to sea level rise, is warmer water getting beneath the floating ice shelves and thinning them, according to Richard Alley, geosciences professor at Pennsylvania State University. Ice shelves surrounding Antarctica, whose melting doesn't add to sea level, act like a cork in the bottle, holding back those ice sheets, as we heard from the scientists earlier, on land from flowing into the sea and greatly increasing the sea level. So all of the ice shelves now are generating friction with their sides or with local seafloor highs that they scrape across. But ice shelf loss removes that friction and allows non-floating ice in that ice sheet to flow more rapidly into the ocean, raising the sea level, he wrote to Manga Bay. Global warming has already happened, that has happened, certainly commits us to further sea level rise, said Robert Larder. He's a marine geophysicist. As oceans and ice sheets will take a long time to reach equilibrium. He, however, stressed that all is not lost. Records in ice cores and marine sediment cores from the last interglacial period around 125,000 years ago, when average global temperatures rose gradually to a maximum that was still a little warmer than today, provide some reassurance that we probably have not reached a point of no return. So they're talking about the greenhouse gas emissions scenario. 80% of the emperor penguins could be gone, quasi-extinct. And this was sea extent, a new record low in this graph, which I think we also looked at something like that earlier. Globally warm plight of the emperor penguins, and this is where I don't want to cry. Climate change has also come hard ashore in Antarctica. In January, BAS scientists discovered a new colony of emperor penguins in West Antarctica, raising the number of known colonies on the Antarctic coastline to 66 in total. Great news? Well, not exactly. Typically found in remote and often inaccessible areas, the species endemic to Antarctica, they depend on bitterly cold temperatures and stable sea ice as a breeding habitat, with chicks fledgling in December or January. Among breeding locations, they mostly target the windward side of bays, headlands, and glacier tongues and ice shelves, BAS researchers wrote in a 2020 study, in which they reported that 11 colonies located in regions that were not identified as possible climate refugia, suggesting population declines could be greater than anticipated in those colonies as warming escalates. Emperor penguins are particularly vulnerable to the loss of sea ice, rising temperatures, and altered wind regimes. And the newly found colony is no exception. Not only is it small, home to just 500 birds, which could be detrimental to its persistence and survival, but it is also located in an area badly affected by recent sea ice loss. If we find more colonies in more marginal habitat, it means that a greater percentage of the population is likely to be affected by sea ice loss in the future. That was Peter Fratwell. The more recently found colonies are all in the category. So in 2019, a study projected that under business as usual greenhouse gas emissions, 80% will be gone. They'll be quasi-extinct. But if the world were to cap temperature rise at 1.5 C, this would, well, just 19 to 31% of them. Monitoring the future colonies will be part of counting the cost of climate change, Fretwell said. The species currently listed as near threatened on the IUCN Red List points to the vulnerability of ice-dependent animals even before extreme warming has occurred. So Antarctica tomorrow. It's do you want to read the end of this?
Okay.
Go for it.
Antarctica tomorrow. Antarctica's geographic isolation and extreme climate have historically spared it from the most of the environmental threats from the rest of the world, but the human-induced warming coming from afar is now overturning this protected status. Whether this is a large problem soon or whether we have a cushion before the warming and other changes become large enough to be dangerous remains deeply uncertain. Many of us believe that the pace of research is at once hugely impressive, but not nearly fast enough to provide the guidance to policymakers that would with confidence allow them to make appropriate decisions well before we might approach an Antarctic tipping point. Being one of the toughest regions to undertake field research, Antarctic data is not as complete or robust as for the northern counterpart. But BAS is optimistic about the future research due to a shift in the way Antarctic science happens, especially incorporating new useful tools to improve modeling. There are grounds for cautious optimism that the worst consequences can be avoided, Larder concluded, with politicians moving from debating the reliability of scientific results to deciding what should be done. What's the chance of that?
Yeah.
Sorry. But national carbon reduction pledges fall far short of the urgency, he conceded. One thing is crystal clear. Already identified Antarctic climate change trends could, if they escalate, have huge consequences for the far distant ecosystems and human communities. As with the northern polar regions, what happens in Antarctica does not stay in Antarctica.
Well, there you go. There you go. This was real. I think we did a very comprehensive job. And the only thing with this last one is that NASA's going to send another rocket up and use a lot of fossil fuels to launch climate monitoring satellites. So we'll have more information. Just like when the Polar Stern was out there and we were excited about that Arctic adventure, now we will probably understand more from this mission, which is the polar radiant energy in the far infrared experiment. So we'll see. It was established to determine how much of the Earth's heat is lost to space and how this impacts rising sea level and ice loss. Data collected will focus on Arctic and Antarctica. So 2 small little satellites, and that's it. And we'll get these. We'll get the information, and provided we are here to be able to tell the stories. Yeah. Yep.
Absolutely.
To tell the stories. So that's our show. We went longer because basically I wasn't here. This is the only show this week. And I want to thank everybody for being here. Jennifer, thank you. What have you got to say?
Oh, thank you. Well, I think we're just really starting to see Antarctica pick up. It's a big continent. It's got a lot of ice, but this is a big one. And I think it's pretty interesting and also pretty devastating to watch. There's a lot of sea level rise wrapped up in all of these glaciers, and they're going to start slipping as the ice shelves dissolve. And other than that, we just continue on and do the best we can.
Every day. All right. Well, everyone, we have a little parting gift video for you to enjoy. Thank you. And you will see us next week, as always.
Let me make it clear, it's really cold down here, so be sure to wrap up warm and tight. You'll need some blubber or fur, or a coat if you prefer. You don't want to lose a toe in the night. Antarctica, Antarctica, it's our frozen home on the southern pole. Antarctica, Antarctica, it's our frozen home on the southern pole. See the penguins dance, spot an albatross. The baby seals do like to giggle and laugh. Our giant bergs are all ice, a little ice is alright, but you wouldn't want some in your bath. Antarctica, Antarctica, it's our frozen home on the southern pole. Antarctica, Antarctica, it's our frozen home on the southern pole. But we're shrinking, our home's sinking. The poles are getting smaller every year. It's making us think we'll be extinct? Do you want us all to disappear?